So hi guys, today we have question 3 from Objective 1, Chapter 15, Wave Motion and Waves on a String. The question says, which of the following equations represents a wave traveling along y-axis? And we have 4 options given. Now in the general wave equation, we write y is equal to a sine omega t minus kx plus phi, where a is the amplitude of the wave, omega is the angular frequency, t is time, k is wave number, x is position, and phi is initial phase angle. But we must know what y and x signify here. So the particles perform SHM along the axis to the left hand side of the equal to sign. That is, if I say y is equal to a sine omega t minus kx plus phi, I mean that the particles are performing simple harmonic motion along the y-axis. Whereas the x inside the sine function, which is clubbed with k, shows the overall direction of travel of the wave. So in this case, it would mean that the wave travels as a whole along the x-axis. Now, I've taken a random screenshot of a sine traveling wave and marked two random particles 1 and 2. Now let's say the wave is moving along the positive x-axis. Random particle 1 and 2 both are performing simple harmonic motion along the y-axis. And we must note that in waves, it's a collection of particles performing simple harmonic motion, and their combined effect gives us the impression of a wave traveling forward. The particles are always performing SHM perpendicular to the axis along which the wave seems to travel. Now, using this information, we'll analyze our options. So option A was x is equal to a sine ky minus omega t. Now we're going to tweak this a little. We're going to make this x is equal to minus a sine omega t minus ky. So what have we done? We've simply changed the ky minus omega t inside the sine function to omega t minus ky. And since we've made this change, we've added a minus sign before a. Why have we done this? We've done this since we must ensure that the coefficient of t is always positive, and since angular frequency can't be negative, we must make the function omega t minus ky. Now, what does the minus sign before a indicate? It simply indicates a phase difference of pi. So as you can see in the diagram, I have shown the wave represented by option A. Now, the dotted line is what the wave would have been had the minus sign not been there. But the solid curve shows what the actual wave looks like due to the presence of the minus sign. And this difference is nothing but a phase difference of pi. Irrespective of these things, the wave still travels along the y-axis, which is what we've been asked in the question, and the particles, they move perpendicular to the y-axis. That is, they perform simple harmonic motion along the x-axis. Now, similarly, using the previous logic for option B, we get that the wave travels along the x-axis and hence it's incorrect. Whereas options C and D are not traveling waves in the first place. They are standing or stationary waves, and hence only option A is correct.